Silence, that is the most terrifying sound in physics. Not an explosion, not a bang, not radiation screaming out of a collapsing star. Silence. Because the universe has been around for roughly 14 billion years, it contains something like 200 billion galaxies, each one stuffed with 100 billion stars. Most of those stars have planets, and we have pointed every instrument we have got at the sky and heard absolutely nothing. Zero. Not a whisper, not a ping, not a stray signal that looks like somebody somewhere turned on a transmitter. Just silence. And that silence, if you understand what it means, should scare you to death. Now let me tell you how this whole thing started, because it is a wonderful story. Because it is the summer of 1950, Los Alamos, New Mexico. A few physicists are walking to lunch. Enrico Fermi is there, Edward Teller is there, a couple of other fellows. Somebody mentions a cartoon they saw in the New Yorker about flying saucers. Everybody laughs, they start joking about aliens, about faster-than-light travel, about little green men. Normal lunchtime talk for a bunch of physicists who helped build the bomb. And then somewhere between the appetizer and the main course, Fermi gets quiet. He does some arithmetic in his head. You could always tell when Fermi was doing arithmetic because his eyes would go somewhere else for a moment. And then he says very plainly, "Where is everybody?" His friends knew immediately what he meant. Not, "Where are the other people in the cafeteria?" He meant, if the universe is this big and this old and the laws of physics are the same everywhere, then where are all the other civilizations? Why is nobody here? Why is nobody called? That question has been sitting on the table for over 30 years now, and nobody has given a satisfying answer. So let us do what physicists do. Let us investigate. Let us follow the evidence and see where it leads, even if the conclusion turns out to be uncomfortable. First, we need to understand just how unreasonable this silence is. Let me give you the numbers, and I want you to really feel them, not just hear them. Our galaxy, the Milky Way, contains roughly 200 to 400 billion stars. Let us be conservative and say 200 billion. Now, how many of those stars have planets? We used to guess. We do not have to guess anymore. The observations tell us that most stars have planets. Maybe 70–80%. Some estimates go higher. So let us say, conservatively, 100 billion stars in our galaxy alone have planetary systems. How many of those systems have a planet in the right zone? Not too close to the star, not too far. A place where water can be liquid, where chemistry can get interesting. The estimates vary, but something like 20% seems reasonable. Maybe more. That gives us roughly 20 billion potentially habitable planets in one galaxy. 20 billion, and there are 200 billion galaxies that we can see. But let us stay in our galaxy. 20 billion chances for something to happen. And our galaxy is about 13 billion years old. Earth is only 4.5 billion years old. That means there are stars out there with planets that are billions of years older than ours. If life got started on any of those planets, even if it took as long as it took here, those civilizations would have had a head start of 1 billion years. 2 billion years. 5 billion years. Do you understand what that means? A civilization with 1 million-year head start on us would be unrecognizable. We went from the Wright brothers to walking on the moon in 66 years. Imagine 1 million years of that, 5 billion years of that. They would not just be ahead of us, they would be to us what we are to bacteria. So the question is sharp. Where is everybody? Now, a fellow named Frank Drake tried to organize this thinking. He wrote down an equation, not a real equation in the physics sense, more of a way to break the problem into pieces so you could talk about it clearly. He said, look, the number of civilizations you should be able to detect right now is the product of several things multiplied together. How fast do stars form? What fraction have planets? What fraction of those planets are habitable? What fraction develop life? What fraction of that life becomes intelligent? What fraction build technology you could detect? And then critically, how long do those civilizations last? You multiply all these things together, and you get a number. Now, this is not a real physics equation. It is more like an organized way of admitting what you do not know. You cannot solve it. You can only fill in your best guesses and see what falls out. But that is exactly what makes it useful. It forces you to be honest about which pieces of the puzzle you actually have and which ones you are making up. And here is what is interesting. For most of those terms, the answer is pretty encouraging. Stars form regularly. Planets are everywhere. Habitable zones are common. Life on Earth got started remarkably fast, within a few 100 million years of the planet cooling down. That suggests life is not a miraculous accident. It is something chemistry does when conditions are right. So the first several terms in that equation look good, promising, almost cheerful, and yet the sky is silent. So something in that equation must be very small, devastatingly small, small enough to cancel out all that abundance. One of those multiplied terms is practically zero. The question is, which one? This is where it gets interesting. This is where we become detectives. Let us consider the possibilities. And I want to be honest with you. Some of these explanations are comforting. Some are not. I am going to give you all of them, and you can decide which one lets you sleep at night. Possibility 1, we are looking wrong. Maybe civilizations are out there chattering away, but they are using something we cannot detect. We have been listening for radio waves. What if advanced civilizations moved past radio waves 1 billion years ago the way we move past smoke signals? Maybe they communicate using something we have not even discovered yet. Gravity waves, quantum effects, something we do not have a name for. We are sitting by the telephone waiting for it to ring, and everybody else is using a technology we have not invented yet. That is possible, but it is not very satisfying because it dodges the deeper question. Even if they are not using radio, where are their engineering projects? A civilization millions of years old should be building things. Big things, things that would change the light coming from their star. Things you could see from here. And we see nothing like that. Possibility 2. The distances are just too vast. Even at the speed of light, crossing the galaxy takes 100,000 years. Maybe civilizations are stuck on their planets, islands in an ocean they cannot cross. But this does not hold up very well either. You do not have to send people. You can send machines, self-replicating probes that travel to a star, build copies of themselves, and send those copies onward. Even traveling at a fraction of the speed of light, such probes could fill the entire galaxy in something like 10 million to 100 million years. That sounds like a long time, but remember, the galaxy is 13 billion years old. There has been plenty of time, more than enough time, embarrassingly enough time. Possibility 3, they are out there, but they are hiding. But they are hiding. This is sometimes called the dark forest idea. The thinking goes like this. Space is dangerous. You do not know who else is out there. If you announce your presence, maybe something bigger and meaner shows up. So every smart civilization keeps quiet. They do not broadcast. They do not build anything conspicuous. They sit in the dark, like animals hiding from a predator they cannot see. Think about it from their perspective. You have just developed radio technology. You could broadcast your existence to the whole galaxy. But you have also just realized that the galaxy is full of unknowns. You have no idea what is listening. And here is the key insight. The cost of being wrong is extinction. If you broadcast and the universe is friendly, you gain a pen pal. If you broadcast and the universe is hostile, you lose everything. The math on that gamble is terrible. A rational civilization might look at those odds and decide to keep the lights off. That is a chilling thought. But think about what it implies. It implies that the universe is full of intelligent life, all of it terrified into silence. Every one of them independently reached the same conclusion: shut up or die. That is a universe with a very different character than the one we have been imagining. Not empty, full and silent. But none of these ideas really explain the depth of the silence. And this is where we have to talk about something that makes people very uncomfortable. In 1998, an economist and thinker named Hanson published a paper with a simple title and a very unsimple idea. He called it the Great Filter. His argument goes like this. Between dead matter and a civilization that colonizes the stars, there is a series of steps. Chemistry has to become biology. Simple life has to become complex life. Complex life has to develop intelligence. Intelligence has to build technology. Technology has to survive long enough to spread. That is a lot of steps, and the silence of the universe tells us that at least one of those steps is almost impossibly hard. So hard that out of billions and billions of chances it almost never gets completed. Somewhere in that chain there is a filter, a wall, something that stops nearly everything dead. The question, and this is the question that should keep you up at night, is where is that filter? Is it behind us or ahead of us? Let us think about what it means if the filter is behind us. That would mean that one of the early steps getting from chemistry to life, or from simple life to complex life, or from complex life to intelligence, is astronomically unlikely. We made it through by sheer dumb luck, a 1 in a trillion accident. In that case, the universe is not full of silent civilizations. It is genuinely empty. We are alone, maybe the only intelligent life that ever arose in the observable universe. That is lonely, and it is strange, but it is not scary. It means we already passed the hard part. But what if the filter is ahead of us? What if getting to our stage is the easy part? What if the hard part is surviving what comes next? What if every civilization, once it reaches roughly our level of technology, destroys itself? Think about that. Every single one. They discover nuclear physics. They develop the ability to alter their own climate. They build weapons that can sterilize their planet. And then, in a cosmological blink of an eye, they are gone. The lights go out, the radio signals stop, and the universe goes quiet again. If the filter is ahead of us, then we are not special because we are rare. We are typical, and we are walking toward the same cliff that every other civilization walked off. Now here is something most people do not think about, and it is genuinely one of the most disturbing logical conclusions in all of science. If we want to know where the filter is, there is a piece of evidence that would tell us, and that evidence is life on another planet. If we send a probe to Mars or to Europa, one of Jupiter's moons, and we find life, microbes, anything most people would celebrate, it would be the greatest discovery in the history of science. Front page news, champagne corks popping, but a physicist should go pale. Because if life arises easily, if it popped up independently on Mars and on Earth, then the filter is probably not in that early step. Life is not the bottleneck. And if life is not the bottleneck, then the filter must be somewhere later in the chain, closer to where we are now, or worse, just ahead of us. So the more common life turns out to be, the more we should worry. Every piece of evidence that says life arises easily is a piece of evidence that says the thing that kills civilizations has not happened to us yet. That is a terrible conclusion. Finding microbes on Mars would simultaneously be the most exciting and the most frightening discovery our species has ever made. And the worse the news gets, the more complex the life we find. If it is just amino acids, organic molecules, well, that is suggestive but not conclusive. Chemistry does interesting things, but if it is actual cells, reproducing organisms with their own genetic code, unrelated to ours, that pushes the filter further down the chain. And if, God forbid, we ever found fossils of complex multicellular life on another world, creatures that had evolved and diversified and then gone extinct, that would be the most terrifying discovery imaginable, because it would mean that life gets to that point routinely and still does not make it. The filter would be very close to where we are standing right now. Let me come back to the physics for a moment, because there is something beautiful hiding inside all this dread. The speed of light is not just a speed limit. It is a wall between civilizations. Information travels at that speed, and no faster. Light from the nearest star takes 4 years to reach us. Light from the center of our galaxy takes about 30,000 years. And the universe is expanding, which means that distant galaxies are moving away from us faster than light can bridge the gap. Some parts of the universe are already permanently unreachable. Not unreachable because we lack the technology. Unreachable as a matter of principle. The physics itself draws a boundary around what you can ever know, ever touch, ever influence. And this has a strange consequence for our mystery. Even if civilizations are common, even if the galaxy is absolutely teeming with them, there is a horizon problem. A civilization on the other side of the galaxy could have been broadcasting for 1 million years, and those signals are still on their way. We might not be alone, we might just be early, or our mailbox might be full of messages that have not arrived yet. But that is a bit too optimistic, because remember, the galaxy is old, 13 billion years, and the kind of probes I described, the self-replicating ones, could fill the galaxy in 100 million years. That is less than 1% of the galaxy's lifetime. There has been time, mountains of time, oceans of time. If anybody was going to fill the galaxy, they should have done it by now. So we come back to the silence. I want to leave you with something to chew on, something that has no answer, and I think that is what makes it worth thinking about. We have this one example. Us is one planet, one civilization. And from that one example, we are trying to deduce the fate of all possible civilizations everywhere. That is like finding one fish in the ocean and trying to figure out the entire ecosystem of the sea. We do not have enough data. We may never have enough data. But the silence itself is data. The absence of evidence is, in this case, evidence of absence or evidence of something worse. Either we are extraordinarily rare, a freak accident in a dead universe, or we are ordinary, and something ahead of us is extraordinarily lethal. There is no comfortable middle ground. The silence forces you to choose, and neither choice is easy. People sometimes ask me, does physics ever frighten you? And I say, physics is too beautiful to be frightening. But then I think about this problem. I think about the quiet sky. I think about all those billions of planets, all that time, all those chances, and the silence. And I have to admit, there is something in that silence that I have not been able to explain away. Something that sits in the back of my mind, late at night, and will not leave. The universe is not just stranger than we imagine. It might be stranger than we can survive. What do you think is behind the silence? Where do you think the filter is? I would be fascinated to hear what you make of it.